well, welcome to Rob's Fix-It Shop. Another Kiln edition. I've got my friend Jan with me. I've tricked her into getting into glass fusing as a hobby. And so we've got this kiln, but like a lot of the kilns I see, it's got a temperature control that you can turn up, but you can only set one temperature. And with glass fusing, you want much better control of that. So we're going to be using a Novus control. We're going to be replacing all the circuitry in here, and we're going to get us a really sweet piece of kiln here, so we can set the temperature, ramp up, hold, ramp, and really have fine control over the glass fusing. And so we can get the glass kind of looking exactly like we want. So first step is we're going to take a look at the circuit that's already there. Then we're going to figure out how we want to rewire it. And then we're going to rewire with the new control. And then I'm going to show how to use the Novus software to actually set up the new controller and get it working, start it out using the right thermocouple and all that stuff like that. So if you think you might find that interesting, hang on, and it should be a pretty interesting ride. All right, I think we're going to start by pulling off the control here. And this kiln was bought used, but it looks like it's barely been used. Or I don't know if it's been used at all. Okay. All right, so it looks like, yeah, so it looks like the temperature is, so here's the thermocouple right here. Mm-hmm. Looks like it's what they call a type K, because it's got yellow and red, which is typical. And so this here is the thermostat, and we just have power coming in, comes into the thermostat, and then that switches here. That's going to the heating element. Yep. That just switches that on and off. Mm-hmm. And so let's see. So yeah, so it's interesting that this is all just its own unit. It's not tied to the temperature control at all, which is cool. I wish we could save that, but then we'd need to put a second thermocouple in. Oh, okay. But I think what we'll do, let's get out the control and I'll show you how we're going to do that. Okay. So what we've got is solid state relay. And what this does is when it gets an input of 5 volts, it switches line current here. So it's like a light switch that just runs on 5 volts, right? Right. And we've got our controller right here. It's an N20K48. So I've used this controller on a couple of different kilns, and I really like it. And so here we can see it's kind of marked out what we connect our thermocouple right here, so we can use the existing thermocouple. That's just a temperature sensor. Mm-hmm. And then this is where we connect our solid state relay to these two. And this just outputs a voltage when it needs to turn it on. And this is the power coming in, 120 volts. So it's super simple to hook up. So let's just draw that out real quick. Okay, so I'm just going to do that from the, okay, so we've got our plug, got 120 volts, right? Mm-hmm. That comes in. And then on the other end, we've got just a coil of wire, right? Mm-hmm. And really what we want to do is we want to be able to turn this on and off. And if we just put 120 volts across here, it's going to glow red hot, and it's going to heat the kiln up, right? Mm-hmm. But on a controller like the one that's already in here, what we've got is remember that black thermostat I showed you? Yep. That's got 2 functions. One, it's got an on and off switch for power, so that when you first click it on, it's going to turn on power. Mm-hmm. But then it also has another switch that's a thermostat, right? Okay. And depending on where you turn it, this piece of metal is going to kind of heat up and kind of open up. And it's not really measuring the temperature inside the kiln. It's measuring, or it kind of is, kind of isn't. And anyways, it's going to then be connected to here. And then this is going to go back to the plug like that. There's also a indicator light, right? And then the indicator light is going to be hooked to this switch here. So I should have done it the other way around, but essentially your indicator light looks a little like a skull, is going to be hooked up like that. So that when you first turn it on, the indicator light's going to go on, and power is going to come through here. This is going to be a thermostat, and then that's going to turn that on like that, right? But that is not how we're going to have it.
Okay.
So what we want to do is we want our coil of wire normal, right? We got our plug on the other end. So we want to come in and we want to have a switch. So we're just going to use a regular switch, a toggle switch. And then we're going to come into the controller and wait, N20K48, right?
Okay.
And we're going to have our power go straight to it, and then we're going to hook 2 wires up to our thermocouple, because that's going to be sensing the interior temperature of the kiln. And we'll see that as we go along.
Okay.
And then we're going to hook 2 other wires up to what they call an SSR, or a solid state relay. And what the solid state relay does is when it gets 5 volts, it allows voltage across its other 2 pins. And so what we're going to do is we're going to hook one of those pins up to the coil of wire, and then we hook the other coil of pin.
Wow, okay.
Up to here, right?
Okay.
And so really what you're doing is this is just acting like the thermostat was on the old one. But there's a big difference. With this type of a controller, you're not just turning on, staying on for a while, and then when you overshoot the temperature, so if you think of like your target temperature, let's say you want to be here, with the thermostat, you're just going to be railing up to here, and then you're going to overshoot it, and then you're going to shut off. Then you're going to undershoot it and turn on, right? And that's kind of the thermostats like that. That's called hysteresis. It's how much you have to overshoot and undershoot to not burn out all your contacts and stuff through overuse. But what this controller will do is that if you have a target temperature, it will work its way up to it, and then it'll start ramping off as it gets close to it, and it will hit the temperature, right? And we'll get into that more later, but this is what's called PID control, right? And it's used in all kinds of control circuits, but it's really nice. And the difference is that these are going to be on for minutes at a time, where with this, if we're like right here and we're trying to get like full power, we're really trying to get there, it's going to have a waveform that looks like this, where it's on most of the time.
Okay.
Right? But if it's getting close and it just wants to add a little bit of heat, it's going to just turn on, shut off, and it's going to pulse like that. But this is, I think it's half a second, 500 milliseconds, or half a second, so that it's pulsing very quickly. And so you'll hear that in the kiln. You'll hear it, but it's a much more efficient way of getting to temperature and holding at that particular temperature. And that's why these controllers are so sweet, is because they give you the ability to really have reliable temperature control compared to these, which are really, this kiln, the way it was just meant to go to a temperature and stay around that temperature point. So, yeah, so that's what that's what we want.
Sure, okay.
Yeah. And obviously this is going to be connected up to the other side of the plug.
Okay.
Right. So, so really, I'm going to draw a little bit simpler, but really what you've got, the core of the circuit is the heating element, going through that SSR, through a switch, to the plug. And this is going to have a signal coming in with pulse width modulation, they call it. That's going to be going to our controller. Our controller is going to be powered after the switch also, and then it's also going to have input from the thermocouple. Okay. Type K. So anyways, that's a much better drawing. So we get better as we go along.
Okay.
so let's get that done.
All right.
Okay, so I think to make this easier to work on, I'm going to disconnect the heating element, and then we can get this kiln out of the way. Should make it a little bit easier. All right. Then I'm going to disconnect the, I thought I was going to disconnect. Okay, much nicer. All right, shut off.
Okay.
All right, so I think the first thing we want to do is just, let's gut it. Let's take this stuff off, and we'll take this out. We'll leave this in because the lights are fun. And it's interesting that there's no external circuitry to this temperature controller. I mean, this temperature gauge. Anyway, not important. So I think we can unplug this. Unplug this. And okay. And then I think we can reuse those. Interesting. So I think we can I think if we take a thermocouple, like this is just this is a type K thermocouple there, okay, right? Mm-hmm. And so this is a thermocouple just generates a small voltage when it gets hot, and so I think this is just essentially a voltmeter with temperature written on it. Mm-hmm. And so if we hook that up like that. But generally with thermocouples, they are at room temperature, the voltage is 0. Weird. Then if you heat it up.
Oh yeah.
Yeah, interesting, huh?
Mm-hmm, yeah.
And then I think my blower is it's at Celsius, so it's there, that's why the difference, but
oh yeah.
Anyways, and I'm burning my hand, so.
Well, don't do that.
Yeah. Anyways, but that's generally how a Type K thermocouple works. Is it's just two pieces of wire, different kinds of chemistry of wire, and they're kind of twisted together and then kind of fused at the end. Mm-hmm. And then that difference in the types of metals generates a small voltage when the temperature is in certain ranges.
Ah, okay.
So. None of that is necessary for understanding how this project is going.
But it's interesting to know why it wasn't hooked to anything else, really.
Yeah, exactly. So I think what we're looking at, I think this is going to be perfect in here, except that we're getting kind of close to the bottom. Mm-hmm. And this connector here goes into the bottom like that. And but we're kind of stuck there, but that's okay. And USB also goes into here, right? Mm-hmm. Which
That's not, yeah.
not a great
great.
thing. I don't know why they didn't put it on the top, but so I think maybe what we'll do is we'll cut this part out here,
Okay.
and then we'll have access to that part. You're not going to touch something high voltage, hopefully. So
Yeah, hopefully.
so don't do that.
Okay.
So I think what we'll do is we'll put this here, and then we'll take this switch, we'll put that here. That'll be our on-off switch. And I think that's going to look pretty sweet. Okay, so we need to cut that hole. Okay, so it looks like this hole is about the right size. So I'm just going to go on each side of it. And then, where did I put it? Oh, here. So that's that to that. That looks good. And then top to bottom, as far up as we can go. Yeah. So. Oh, is it square? Oh, that was nice of them. 1 3/4. I'll be damned. Okay, well, that makes things really easy. Okay, so we go like that. Go like that.
Ready.
All right. So. Go switch overhead. Okay, I think that looks pretty good. Yeah, it fits. Okay, that's a miracle. Usually I spend a bunch of time filing it because I undershoot. Do we want the light to come on when the power's on in general? Or do we want the light to come on when it's actually engaging the element?
No.
I'm going to say let's do it when the element goes on, because then, because you'll see this thing come on. You'll see the controller come on when the power's on.
Oh, okay, yeah.
Yeah, so let's do that.
So then it's gonna, it'll sort of be flashing on and off?
Yep.
Okay.
Yep. So the next thing we want to do is we want to mount our solid state relay. And the solid state relays, they do produce heat. And so they have these cooling fins for them. I don't use them in mine kiln, but I think we probably should. And so we need to find a place for this, but we also need to be able to attach the wires to it. Right, so I'm thinking maybe we'll go, okay, I made up my mind. Over here.
Okay.
Is that threaded? Okay, so we want to mount this over here, so let's mark that. Is that going to help us? Okay. That looks right, but we won't put it until last, right? We're just getting prepared.
Okay.
And then we just kind of want this plate to kind of fit flat against here, right? So there's just some weird rough paint things on there. And so we're going to put thermal compound between.
Oh, that's what that
So
is.
this thing's going to get hot, right? It's a 40 amp, right? And this is really only 13 amps. So I don't think it's going to get that hot. I think it's just like a watt per amp, but I also don't want to burn your house down.
Thank you. My husband will very much appreciate
Yeah,
that
and it's a
news.
1 in a million that it happens, but you know, you'd really have something on me if it did.
Yeah.
Okay, so let's put the.
I feel like you should put more on. Now that you say that.
All right. You want just the right amount.
Oh, okay.
Okay. So now we got that there. I think that's it for our metal work.
Are we going to have to cut something out of the bottom?
Oh, that's right. Let's see where we want to do that. We just want to cut out enough that we can get to that USB port. It looks like it's 1/8 of an inch, so it's really close. So how do I get that out of there?
Just do the big drill bit.
Yeah, I think that might be the best. That worked incredibly well.
What kind of drill bit is that?
It's a stepper. It's meant to be used for like tin and stuff like that, where it gradually expands the hole.
Oh, I see.
And because if you use like a regular drill bit when you're doing tin, it tends to tear everything apart.
I'm concerned about you losing your drill bits.
We'll make it look like we wanted that arch like that.
Yeah, I think it's beautiful.
All right, so yeah,
Oh,
yeah, so that we should be able to get the USB thingy in there. So now we actually have to start wiring. Okay, so I think what we're going to do is we've got our switch here, and we're going to bring our power, both our black and white, into here. And then we're going to use this to go off to the SSR and the temperature controller. And then we'll have this one be our ground going to the same place. So we're going to use the switch as kind of our starting point for all the fun. And so I do need to take these connectors off and put other ones on. Oops. Okay. We'll pretty this up in a second. Yeah, it's a little bit specialized. It's just for crimping the connectors like that, but you can do it with the pliers, but it just doesn't seem as nice.
I've never used connectors like that before either. I've seen them, but not put them onto anything.
These are really nice because they have shrink wrap on them, and that kind of holds the wire to a small degree, but looks a lot sharper then. All right, that looks pretty good. Kind of pull them so see if they don't come off. Okay. First step done. So we got a power coming in, and then this switch is going to turn it on here and here. So one of these has to go to our solid state relay. So the input of our the output of the solid state relay, one of those sides has to connect to here. So here we've got, we can use in one of these slide-in deals, and the other side will use one of these round deals. Let me get some wire. So you want these connections to obviously be kind of good, right? Because you don't want to, because if they're loose or not connected well, then they tend to smoke
That would be bad.
and burn. Although this is all on a metal thing, right?
That's another thing my husband would not appreciate.
Yeah, well, he's right on this one. Okay, so, and then we're gonna connect our hot lead from the switch. Right, we're not going to tighten that up too much because we also need to add another one to go to the controller. But this can go in here. And so that the wire from here goes right to the coil, right?
Okay.
So power comes in from the plug, through the on and off switch, through to here, and then sits there until this guy, the controller, turns that on. Okay, so we also need then, we need something to go from here to the heating element. And what we had going to the heating element before was this wire. But that's kind of, yeah, we'll use that one. I just got to put a different connector on it. Okay. Remind me I have to heat shrink these.
Yes, I was thinking that same thing.
Okay, so that's one thing that goes in here. Now we want one more thing to go in there, a wire to the light. I was hoping we could get this all wired out outside of the container, or the box, but the light has to go in from the outside, so we're kind of stuck there. And so the other side of the light then will go to the white wire or the ground, not the ground, the common. So that'll probably connect up on the switch. So we'll have three things connected at the switch, so there'll be kind of a lot going on there. Although the only thing that, the controller and the light bulb obviously don't take much power. Okay, so that goes to switch, that goes to thingy, that goes to there. Okay, so now we need this other wire that goes to our controller. No, the heating element. Okay, and that's going to go to the other side of our switch. So the white is going to be switched directly to the heating element. So let me see if I can get this all in here. So I got this, got one more. Yeah, we just need a little baby wire for this. So what we need is we need the ground going from here to the heating element, the light bulb, and the controller. So we have three things coming into here, but on this side we just need it going to the solid state relay and the controller. I just haven't added that yet. And so I'm going to make the two wires right now that are going to go to the controller itself, and we'll even wire that up then. And so what I do is I'll put this little Molex connector on here, and then I'll write so that this is plus on the thermal, this is minus on the thermal conductor, this is output A and minus, and then this is I just put 120 volts so that you know that that's the power source that goes in there. The output pulse goes to there, and the thermocouple goes to there. You're the dog snoring.
Mm-hmm. Oh, yeah.
Okay, those are on there well. How's your garden?
Oh, you know, kind of slow because I haven't been able to put stuff in.
Oh, no.
I could be seeding now, and I probably will throw in some seed this afternoon yet. But I'm just growing flowers. So, but I bought pretty much
Who's
all
going to
my,
feed the rabbits?
well, I'll have to rely on my neighbors for that. Actually, they get very well fed off of my various native stuff, and grasses and sedges.
Right.
Ooh. That was like the big accomplishment of this whole project.
All right. So, switch comes on. We get power to our controller. We have power to going to the light bulb, and then or ground going to our light bulb. So I think we're pretty good here with the switch. I think I'm going to put that in. So what's next, you ask?
What is next?
We want to connect the controller to here. And so we'll use this wire. All right, so let's hook up the SSR, and we want plus, which is our yellow, which I randomly picked. Go there. See, that's why I like these better, because then you can just slide them in like that.
Oh, yeah.
Then we'll take this. Slide it onto there. Okay, that's in there. That's in there.
Okay.
Okay,
Slip.
and so now we have to hook our ground up, obviously. I don't know where it must have been hooked up somewhere before. I don't know where. Let's drill a hole for that.
Okay.
Okay, much nicer. Okay, so now got this and this, right? That's good. And then these little holes. Well, that's the theory, at least. Fold it under, push it back. Ta-da!
Yay, look at that.
We are no longer a bead annealer. Okay, so we've got our thermocouple here. And with the thermocouple, the wires really make a difference. No, the yellow is positive and the red is not. And this thermocouple is wired directly, but sometimes you'll have the wires come and they'll attach. The wires can't be completely switched either because these wires are made of a particular metal. Mm-hmm. So it's a little bit, if you're doing it from the start, it can be tricky. But if you've already got one side permanently hooked up like this one, if you put it in backwards, the temperature will go down when it's supposed to go up. So that's how you can kind of tell that you've screwed it up. So I've read. And we'll see how to set. So these controllers will work with a bunch of different kinds of thermocouples, but we'll see how to set that. Okay, that looks good.
Right.
Those are nice thermocouple wires, I've noticed. Okay, so now we have to get this
The other hard part.
down into here. And I think we'll do it by putting those like that. Oh yeah.
Okay. You knew it was going to work all along.
Uh-huh. So we could have drilled out the rivets here and here, and just replace them with screws later, and then taken this bottom panel off. But
Sure.
I think that's going to be good. And so now we want to reattach power to the element. One. Okay. think that's it.
All right.
Okay, so we've got the wiring all done. We've got our fancy hot wires there. And I think I'm off, so let's try turning it on. And oh, then the
Ooh.
controller comes on. Okay. Okay, before we go too far, let's just set up the controller. Okay, so let's get this device set up, and we're going to go through Bluetooth. So the first thing we need to do is we need to add it as a device. So if we add device, Bluetooth, we want to show all devices. And here we got the serial number of the device. Click connecting, and now we're connected. So once we're connected, then we can open up QuickTune, which is their software. And read device. And sometimes read device, I have to click it twice. We're going to go through Bluetooth. See, it's not finding it. Okay, so I just had to do a read device, then it found it. All right, so one thing to kind of know about this Kiln is manual control and automatic control. I always use automatic control. Manual control just means you're going to take the manipulated variable, which is from 0 to 100%, and it's just going to pulse the heating element at that rate forever, right? No matter what temperature it is. So I always go to automatic control, right? So then we're going to go to basic, set it to our temperature unit that we want, automatic control, and we have to set our what type of sensor we have, and we have a type K thermocouple. Set our lower limit, and we're going to set our upper limit. And sometimes this control acts a little wonky, so I usually here I'm going to set this to, it looks like it's comparing, making sure you don't go below the lower limit. But so I'm going to come in here and let's set it for 1800 degrees. Our control set point, let's just set that for 100 degrees. Doesn't matter because we'll be setting that. So if we wanted to just bring our kiln to a particular temperature, we would set the control set point. And that's pretty much the temperature. And okay, so let's set that for 200. And then we have to tell the controller, what do you do when you want the temperature to go up? And we hooked our solid state relay up to out A function. And so we just need to say that that is our control output. And out B, we're not worried about that. Auto tune, we're not going to worry about that right now, but we will in a little bit. And for our device SSD, this is the serial number, but you can change this to a name that you like a little bit better. But that's the name that's going to show up when you do Bluetooth. So let's send to the device. And so there you can see that our device is actually showing that we set it to 200. And if we go here, we can say run yes. And you see that it's outputting to output 1. And then it's running. Oh, I don't have it. Hang on. Now you can see our green light is coming on because our coil is coming on. And let's go back to here, and we can see that our temperature is going up. Yeah, so it's going up pretty fast, right? Because it's kind of a low temperature. But then once we go, then we see we shut off there, and we're we're trying to hold it there. But the thing to remember is that this controller needs to be kind of set up so that it works with the kiln that you have, right? And so what we need to do next is we want to auto tune. And what auto tune does is it sets up the PID control circuit to be optimized for the particular kiln that you have in the temperature range that you like. So let's do the auto tune now. Okay, so let's auto tune our kiln. And what auto tuning does is it picks a set of control parameters that are optimized for the kiln that we're actually using, right? Because everything makes a difference: the size, the height, the coils, everything. So what this does is it actually tunes based on what you've got. So what we're going to do is we're going to go in and we're going to click on Basic. We're going to pick the control set point, and I'm going to pick 1,000 degrees because we want to pick the point at which we want the best control. And 1,000 degrees, I think, works well for glass work. And then we're going to select Auto Tune, Full Tuning, and then we're going to say Controlled Enabled. And so what Controlled Enabled does is it actually turns the kiln on. It says Start Heating. And so if we send that to the device, we can see that we're running. We've got our output is to output 1, and we're tuning, right? And so what we're going to do is we're going to drive up to 1,000 degrees. We're going to go a little bit above it, and then it's going to shut off. And so what it's going to do is it's going to try to find the best parameters for heating, and then it's just going to hold at that temperature. So let's just watch this for a while. So if you're doing glass fusing, right, like here's some fusing that I've done, and like what I've done is I've kind of experimented with different temperatures, but generally what you want to do is you want to ramp up, and I usually ramp up pretty fast up to around 1,200 degrees, and then I let the kiln kind of adjust to a higher temperature, and then I jump up to my final temperature. Then I come down to the annealing temperature. So this is this is where we melt, this is where we anneal, and I hold it there, right? And then I slowly come down and cool, right? But if you look at the charts for doing this kind of work, you know, they'll say like a full fuse like this is, you know, 1,450 degrees, right? Well, in my kiln, like my, not this kiln I'm working on here, but my other one, that actually happens at 1325, right? And so the thing to remember is that when you're working with these kilns and kind of playing with getting your glass right, it doesn't matter what they say the advertised temperature is. It's whatever temperature you read in your kiln, right? And so once you get your kiln set up, you're going to want to experiment to kind of get the glass to look the way you want, right? And so what I do is I experiment with different temperatures, and then I could say, oh, if I want it to look like this, I need to use this recipe. If I want it to look like this, I need to use this recipe, right? I don't know if you can see that, but I engrave the number of the recipe that I've got in the glass, right? And so when I use temperatures here, you got to remember that you need to experiment with your own kiln and get the temperatures you want. But getting a ramp soap program like this is why I really like this controller, because it makes it really easy to do that. And here, I'll show you how to do it. Okay, so for doing our ramps and soaks, the QuickTune program does have kind of a convenient way to do it. So we can come into our features, ramp soak programs, and we can say we want ramps and soaks, and want to select hours and minutes, and then we're good here. And then we can come down here and use the ramp and soak tool, and it's going to kind of help us to enter our program, and it will kind of show us. It's a little buggy too, so you got to be a little bit careful. Do not use tab to go between controls, because that seemed to have a lot of weird results. But let's say we want to look at this program here. Here I went to the Delphi. So here I went to the Delphi glass firing guide, and there's a lot of good information on here, but really you have to kind of experiment on your own and kind of figure it out. But here what they're doing is they're heating up to 1,000 degrees. They're holding there, or they're heating up to 1,000 degrees at a certain rate, 500 degrees per hour, and then they're going to 1465 to get it to the melting temperature, and then they're holding it there for a while, right? That's the thing. So that's what's going to make the difference, is you get up to the melting point and then you hold it there, and that's how you get your different effects of how much the glass melts together. And then they're saying cool down to 1,000 degrees as fast as you can. Wait there about 8 minutes. And then you want to have your first annealing at 960 degrees. Hold there for 20 minutes. Cool down to 800. Don't worry about holding there, but then see, you're going at a different rate down to 800, kind of slowly. And then you want to cool down to your room temperature in a couple of hours, right? So that's an example of a program. The one I've generally used in the past is a little bit simpler than that, but that's okay. So we're going to look at this, and we're going to enter this into our program. And so first thing we want to do is we want to set our initial temperature, and that's going to be, I don't know, 65, whatever it is. And so we want to go to 1,000 degrees in about 2 hours. Whoops. 1,000 degrees. Okay. And then we want to go to 1495. And you want to do that kind of quickly. And so we're going to say in about 30 minutes. It's kind of what your kiln can do, right? Going from 1,000 to going up 500 degrees, you're going to be kind of, it's going to be what your kiln can do. You'll have to pay attention to that. And then we're going to hold there for, let's say, 15 minutes, right? So here we're seeing this hold for 15 minutes. Then we're gonna go down to 1,000 degrees, and it says to do it pretty quick, so let's just leave it at 15 minutes. It'll cool down pretty quick. Actually, I don't think it'll cool down that fast, so let's go to 20 minutes. I don't know. Again, you got to learn your kiln. And then, oops, I'm sorry, I went to the wrong one. Yeah, so we want to go down to 1,000 degrees in, let's say, 30 minutes. Or as fast as we can. I mean, it depends on your kiln, right? And then we want to go down to 960. In about, let's see, so this is saying about 300 degrees per hour. So let's say, I don't know, 20 minutes. And then we're going to hold there. For 20 minutes. Then we're going to go down to 800. Going to do that in about 30 minutes. We're going to take our time with that. And we're going to hold there for, what do they say? Oh, it doesn't say to hold at all. So let's go to then 65 degrees in 2 hours. All right, so there's our program. And I think we can kind of adjust these numbers like this and you know, adjust our wait times. But like I said, it's a kind of a handy way to do a ramp soak program, and there's 9 of them, so you can kind of create these and save them. You can save them and recall them, but once you've created it, it's stored down on the controller. And so that then if I went to the next one, I could create all the profiles I want for the different types of fusing I want to do, whether I want to do just a slump or a mix or whatever. And so you can do that through this program here. And so then when I'm done, I apply the ramp soak. I send to the device. And then I can just enable it and send to the device again, and it's going to run through that program. So it's pretty easy. It gets a little bit funny because of the, you know, people like say, oh, here's a ramp soak program, and they'll have it in the rate, right? 500 per hour. And weirdly, this application has the rate in degrees per minute, which is strange, but whatever. Anyway, that's just a kind of an introduction for how to do that ramp soak programming. Well, that's it for Rob's Fix It Chop Kiln Edition. And I really like this controller. I think it's pretty nice. I do have the ability to also, like, I've written a program myself to talk to it over the serial line, but I think it does a really nice job of controlling. It's easy to use. All the things I showed you through the user interface, you can do through the front, but it's kind of difficult. But anyways, it's nice to get this kiln up and running. And just a couple of hints. Number one, this is not a tutorial. I'm just showing you how I did it. Number two, you want to make sure you use components that are rated for your particular kiln. This one is about 13 amps. And so, like, when I'm trying to pick wires and that, I want to find ones that are that are not going to melt when I do that. And but I think it's really, you really end up with a nice something nice when you're done. And so it's really worth the effort to kind of get that better controller on here and then get to your glass work. So if you enjoyed the video, please hit like and subscribe, and thanks for watching.